Let's discuss these examples, the asymptotes of these examples. So we have to consider two types of asymptotes, the vertical asymptotes and the horizontal asymptotes. So for vertical asymptotes, we look at the denominator. But this problem here now, we have a square root in the denominator, right? There is a square root. So it means that if there is a square root, we have to consider, before we looking at the function here, the asymptotes here, we have to consider what's the domain that can accept by this function. So as you know, that what is domain? Domain is the value of x that can be accepted as an input, and so that there is an output here. So now x squared, so it means that for these cases there is a square root here, so it means that the x squared minus 3x minus 4 must be at least 0, right? For square root, it must be at least 0, the value inside. But for this case, it's even special because the square root here is on the denominator, right? It's on the denominator where it also cannot accept 0. It must be greater than 0. So that we have to look at the domain for this problem here. So as we factorize, we were getting x, 1, 4, negative and positive, right? So x squared. So if you're solving these inequalities, you have negative 1, you have 4, greater than 0 means that the region, so means that the domain of f here, you can be accept from negative infinity up to negative 1 or 4 up to infinity. I tell you why. So you choose any value. You choose any value within this range. You choose 5, for example. 5 squared minus 3 multiply 5 minus 4. You are getting a positive number. It's okay. If you choose any number, negative 2, you're putting here. You try first. Negative 2 squared. So negative 2 squared, you have 4. 4 plus with 6. 4 plus 6 you have 10. 10 minus 4 you have 6. So it's okay. It's a positive number. But if you choose a value not inside here, for example, between negative 1 and 4, there's a 0. If you're putting 0 here, you are getting negative 4. Square root of negative 4 is not defined, it's undefined. So this one, there are no output here. So it means that this square root is only accept certain value. That this is the value that they can accept here. So now, I write the domain here as a reference. The domain is very important. So, right? So you have to consider domain for this case here. The domain means the value of x that can be accepted. So now I'm going to erase this. So this is the knowledge of function. So but how to using the knowledge of function in finding the asymptotes here, the vertical asymptotes here. So as you can rewrite this thing as x over with square root of x plus 1, x minus 4, right? So x squared, negative 4 plus 1, so minus 4. So you can rewrite this as a in this form. So now I want to evaluate. The limits. So you know that x cannot be negative 1, right? And x also cannot be 4, right? So why? Because as x is negative 1, so the whole thing here, we're getting 0, right? Where on top, negative 1 over 0, which is undefined. 4 also, if you're putting 4 over 4 minus 4 is 0. So you're getting a number divided by 0. So this is the case where you produce a asymptote, a vertical asymptote here. So we have to consider the right hand limit and the left hand limit, right? So we have to consider the right hand limits and the left hand limits here. Alright, so but because this is a square root, then we have to refer to the domain, the value of x that can be accepted here. So negative 1 plus is something greater than negative 1, right? Something greater than negative 1, which is not in the range. Negative 1, greater than negative 1 from the right. So means negative 1, for example, from the right. Negative 1 from the right, negative 1 from the left. You can choose a value. Don't too far, around negative 0.5. Here maybe it's 0.5, for example, negative 1.5, right? From the left, from the right. So if you're choosing negative here, negative 0.5 is not in the range, right? It's outside the range. So this is negative 2, negative 3, this is 4, 5, 6. So this is not in the range. So means that for this function, limits for right hand limit for that is undefined. Is undefined. So we don't need to consider the right hand limit. Special case, only for square root. The rational function there is with a square root there. So, but for this one, you need to consider x squared minus 3x minus 4, right? For this function here. So, okay. So you know that this type of cases, when you substitute a value here, a negative 1 here, and you substitute here, negative 1. So you imagine negative 1 plus 1, you're getting 0. 0, so 0, you know. So this is a case of a over 0. The answer is always infinity. The outcome, the limit of this function is always infinity. But positive of negative is, we need to consider the limits here. So as you know that negative 1. So as x is negative 1, of course this will be negative. So for here, the square root, you don't need to consider any, because square root of any number you are getting positive. So this one is always positive. So negative, positive, you have negative infinity here. So negative 1 is a vertical asymptote. As the right hand limit undefined, never mind, but this side, the left hand side, you're getting infinity. So it means that x equals to negative 1 is a vertical asymptote. Alright, so let's consider 4. 4. So as you know that you have to consider, suppose you have to consider both sides. You have to consider both sides. From the right and from the left means that 4 from the right and 4 from the left. So from the right here, from the right but not 4, you maybe can choosing 4.1, 4.5. And from the left here, you maybe can choose 3.8, 3.9, any number, okay? Less than 4 a little bit. So now, if you see that, which one you don't need to consider? We don't need to consider because there is a square root here. Because 4 plus 4.1, is 4.1 in the range? Yes, 4.1 is in the range. So we consider this one. This one we consider. So how about 4 minus, less than 4, 3.8. Is 3.8 in the range? No. Is that it inside here? No. Right? It's not in the range. So means that this one you don't need to consider the limits, and it will be undefined. So 4 plus. So you have x over with square root of x squared minus 3x minus 4. So as you substitute the value, the one-sided limit getting 4. As you put 4 here, you know that this one will be this one. If you put 4, you will getting 0. So a number divided by 0. This type of case, the limits, you always produce infinity. So either positive or negative, we should consider, alright? We should consider the sign here. 4 is a positive number. So as x approaching 4, x also will be positive. But this square root here, the square root here, always produce a positive number. It's always positive. So positive, you're getting positive infinity here. So it means that approaching 4 from the right, you're getting positive infinity. Means that x equals to 4 is also a vertical asymptote. And this one, approaching negative 1 from the left, is going to negative infinity. Means that x equals to negative 1 is also vertical asymptote. So it means there are two vertical asymptotes, which is x equals to negative 1 and x equals to 4 are the vertical asymptotes of this problem. Alright, x equals to negative 1 and x equals to 4 are the vertical asymptotes of fx. So In the same video, I'm going to talk about horizontal asymptote as well. So, but you have to jot down this because I will drawing a graph to show you. I will show you how's the graph go. These two information very important. Is tell what happened to the graph. All right. So now we're going to discuss about horizontal asymptote. Okay, let's continue discussing horizontal asymptote for this function here. So horizontal asymptote, this is your vertical asymptotes, right? Just now you find it, I simplify what you write just now. The limit as x approaching negative 1 from the left, you're getting negative infinity, right? The limit, the answer of the limits as 4 from the right, you're getting positive infinity. All right, so you know that x equals to negative 1 and x equals to 4 is the vertical asymptotes. So now we consider horizontal asymptotes. For horizontal asymptotes, the procedure will be you have to finding the limits of x approaching positive infinity. At infinity, limits at infinity for this function. So you have x over with square root of x squared minus 3x minus 4. And you have to find the limits of x approaching negative infinity, a positive and a negative for the same function here. So x over with square root of x squared minus 3x minus 4. We can accept because x approaching negative infinity is here, right? They can accept very big negative value, can accept very big positive value here. So now the both side, the limits you have to consider. So now I solving this one for you. So but first, you still remember to evaluate a limit. You have to remember all the types of techniques of evaluating a limit. As this one, you know that positive infinity, you're getting infinity. So you substitute infinity, you're getting infinity. Infinity or infinity. And this is a special case. You can refer to the video that I'm talking about the limits, evaluating a limits at infinity for a special case here. So if there is a square root here, so then I have to use this concept as x positive. I can rewrite the x to be square root of x squared. So when x is negative, I can rewrite x as a negative square root of x squared, right? You can refer to the video that I'm talking about this concept here. So now I'm going to using this concept in evaluating these limits. So x over with square root of negative 4, right? So to evaluate these limits, so at first you have to divide up and down by x. Divide by x, and you divide the square root by x as well. So x squared minus 3x minus 4 divided by x. Why I want to use this concept here? Because this one, what x over x, you're getting 1. But this one, you cannot divide because there is a square root controlling here, right? So you have to modify this x here. This x can be rewrite as the positive here because x approaching positive infinity as x in a positive region. So you were choosing this one to be square root of x squared, right? So now evaluate. So you're getting 1 for this. And this one you were getting square root of x squared minus 3x minus 4 over with, now you have square root, you can combine the square root together, right? Finally, you know that limit as x approaching positive infinity. So for 1 over with square root of x squared divided by x squared, you have 1. Negative 3 over x, x over x squared, 3 over x, minus with 4 over x to the power of 2. So as x approaching positive infinity, a number divided by infinity, a number divided by infinity will be approaching 0. So 1 divided by the square root of 1. So you're getting 1, right? You're getting 1. So it means that 1 will be your horizontal asymptote. When you find the limits at infinity and you're getting the value, the value will be your horizontal asymptotes here. So same thing, repeat here. What if I find the negative infinity of this function? So this question is a very complicated cases here. In order to find the vertical asymptote, you have to consider many things. Alright, so I hope you really sit down and understand this section here. So you have x squared minus 3x negative 4. So you have limit as x approaching negative infinity. This is the procedure is the same. You divide by x. Okay, you divide by x. But so x squared minus 3x minus 4 over with x. But this x here now, because of the square root here, I have to modify it such that I want to choose either one of these. And depend on here. If negative infinity, then I will be choosing the negative. The x is negative, I will choosing this one to be negative square root of x squared. So later, you will have limit x approaching negative infinity. This is still getting 1. And here you have negative square root of, you can combine the square root, right? So you can x squared over x squared 1. Repeat the same thing here. Minus 3 over x minus 4 over x squared. As you know, these two approaching 0, right? But there is a negative here, right? Negative 1 over square root 1. So you're getting negative 1. So means you're getting 1 and you're getting negative 1 at negative infinity. Means both of these are the horizontal asymptote. So means that y equals to negative 1 and y equals to 1 are the vertical asymptotes of fx. So you have 4 asymptotes, 2 vertical asymptotes and 2 horizontal asymptote. Alright, horizontal asymptote. So you have 4 asymptotes. Okay, how these 4 asymptotes looks like when it's in the graphical representation here. So, alright, so as x approaching positive infinity, the y approaching 1. So as x approaching negative infinity, the y means this function approaching negative 1. So let's use all the information we have here in sketching a graph. Let's see. Alright. So we have do a long-winded way. That's so tired. So why are you doing all these things? There must be a purpose here, right? So, alright. So you have y. So after you understand the concept of limits, you are the expert of graph. Okay, I can say that you are part of the expert of graph, even though not really yet, but you have already almost reaching getting the concept of graphing here. So now, for example, you look at here, you have square root, you have vertical asymptotes, right? So you locate the vertical asymptotes. You know there is a vertical asymptotes. So, and there have 2, 1, 2, 3, 4. So 4 here, there is another vertical asymptotes. So horizontal asymptotes, you have 2 also, which is y equals to 1 and y equals to negative 1, right? So there is a negative 1 here and there is a 1 here. So you will have 4 asymptotes. So now you see, you have 4 asymptotes here. So but how to using these asymptotes here? So you have to refer all the information here. So as you see that the domain also very important. The domain telling you that there is no graph within negative 1 to 4, right? Because any value within here, there is no output. So you can put 3, you can put 2, you can put 1. You must try, right? You don't just watching the video, you must try. What happened? So when you put 2 inside here, 2 plus 1, positive, okay. 2 minus 4, negative, negative, positive, negative. So square of negative cannot be accepted. So the whole thing here, the whole section here, there is no graph here. So the graph only exists within this region here. So let's look at the vertical asymptote here, negative 1, right? It's only one side. It's only one side is defined. So as x approaching negative infinity, negative 1 from the left, negative 1 from the left, you're getting y getting going down, negative infinity. So let's see. So as the x value getting from the left, from the left. So it means from the left. So you have up and down, right? So you have to look at this one, positive infinity, right? So it means that it's approaching here. -1 as they approaching -1, so it will be going for negative infinity. Means that as x approaching -1, -1 plus, don't need, -1 minus. So now we look at 4 plus from the right. So it means that right and left. So we consider right. During right, approaching from the right, 4 plus, so you are going positive infinity. Means that the curve will be somewhere around here, positive infinity, right? Positive infinity. So that this is the information that we get only. So now we look at this one. As x approaching limits at infinity, so you're getting y approaching 1, right? As you're going positive infinity, a value of x that's very big, the graph will be approaching approaching 1, right? How? Means that from here you have to go down, right? You have to go down. So you will go down and approaching 1. You're approaching 1. So it means that as x approaching positive infinity, the curve approaching 1, right? Y equals to 1. So, but when the x getting smaller, approaching 4 from the right, it's getting positive infinity here. So now go for this one. As x approaching negative infinity, means that approaching here means that getting bigger and bigger, getting bigger and bigger. So the graph will approaching -1, right? Not 1, but approaching -1, right? This is the y equals to -1. So means that must be from here, right? So it will be approaching -1, right? So but when it approaching -1, -1 minus, so refer here, you are getting negative infinity, right? So this will be the graph for this function here. All right. So it's a very detailed video for you, so that hope you really love it. Okay.